Imagine your school has arranged a visit to NASA. The school has also proposed that you can visit NASA if and only if you score more than 90 marks. Notice this statement. This is a conditional statement. It is in the form if and only if. In this section, we are going to discuss about such conditional statements used in mathematical reasoning. First, let us move to if-then statements. Consider statement, if you are born in some country, then you are a citizen of that country. Now observe this sentence. It is in the form if P then Q. Let us write them separately into two statements like you are born in some country and the other one you are a citizen of that country. Here we can say that the statement P explains something happening and the statement Q implies the effect on happening. In this, the statement P does not say anything about the happenings, but the statement Q has no effect with respect to P. Now consider another statement. If a number is a multiple of 9, then it is a multiple of 3. We can write this statement into two statements such as a number is a multiple of 9, a number is a multiple of 3. Now what do you understand from these statements? There are several ways of understanding. If P, then Q statements. We shall discuss about some equivalent forms for the given statement. P implies Q. It can also be denoted with a symbol as shown here. Then the statement P is a sufficient condition for Q. Then P only if Q. Finally, Q is a necessary condition for P. We can discuss all these forms through an example. Consider a statement which we have seen before. If a number is a multiple of 9, then it is a multiple of 3. With respect to the first form, the given statement means a number is a multiple of 9 implies that it is a multiple of 3. That is, the statement P implies statement Q. Then statement P is a sufficient condition for Q. That is, the statement a number is a multiple of 9 is sufficient to conclude that it is a multiple of 3, because we know any number that is a multiple of 9 would always be a multiple of 3. Then we can say P only if Q. This says that a number is a multiple of 9 only if it is a multiple of what? 3. Next, Q is a necessary condition for P. This says that when a number is a multiple of 9, it is necessary that it should be a multiple of 3. Then node Q implies node P. That is, tilde Q implies tilde P. This says that if a number is not a multiple of 3, then it is not a multiple of 9. We can notice that this statement is contrast of the original statement. So, this is a contrapositive of the original statement. Alright, let's see another statement. If x is a prime number, then x is odd. The contrapositive for the given statement is if x is not a prime number, then x is not odd. Alright. Next statement is something is cold, implying that it has low temperature. Now what will be the contrapositive statement for this? If something is not cold, then it does not have low temperature. Alright. This is what is called contrapositive statement. Now we have to focus on converse statements. The word converse means just reversing the statement. Consider a statement. If a number is divisible by 10, it is divisible by 5. What is the converse of this statement? If a number is divisible by 5, it is divisible by 10. We have just reversed the statements. Let us look on some more examples. If you do all the exercise in the book, you get A grade in the class. What will be the converse? If you get an A grade in the class, then you have to do all the exercises in the book. Alright? And the example. If two lines are parallel, then they do not intersect in the same plane. Now what will be the converse? If they do not intersect in the same plane, then the two lines are parallel. Right? Hope you are clear with the if-then condition which we have discussed here. Now, let us concentrate on if and only if condition. If and only if. Let us see some equivalent forms for the given statements P and Q. First one, P if and only if Q. Then Q if and only if P. Then P is necessary and sufficient condition for Q and vice versa. And if and only if is represented using the symbol which is shown here. Here, both the end has arrowheads. Alright. Now, let's see one example. We are having two pairs of sentences. Now, combine these two statements using if and only if. If, my question is, if a rectangle is a square, then all its four sides are equal. So the answer can be given as a rectangle is a square if and only if all its four sides are equal. Right? Hope this is clear. Next, if the sum of digits of a number is divisible by 3, then the number is divisible by 3. So, how we can write it? If a number is divisible by 3, then the sum of its digits is divisible by 3. It can be written as a number is divisible by 3 using if and only if. How we can write? A number is divisible by 3 if and only if the sum of its digits are divisible by 3. So, we have discussed about some conditional statements. Next, we need to check this condition which we will be discussed in the upcoming video. Now, let's have a quick recap of what we have discussed.
Manorama Horizon. Learning made simple.